So I'm here today to talk about pyATS and Genie, and the talk is about discovering network problems before they become problems. And so without pyATS and Genie, the way that we would normally debug networks, you'd have a whole bunch of show commands, as seen on the left here, and you'd get a whole bunch of output, as seen on the right. Now, the issue with debugging this way is it's slow because you might have thousands of lines of output. You might have a diff like this, whereas on the left side, you have something that was working. And on the right side, you have something that's not working. And the issue with this diff, there's a lot of information that's not very relevant to the issue at hand. For example, in this diff, the only part that is relevant is actually the Ethernet 1/1 was up, but now it's down. So everything else isn't really relevant to the issue. So this is where pyATS and Genie, the test automation framework, comes into play. And originally, it was intended for internal engineering use, and it was used for in CI/CD across multiple product platforms and groups, and it's been in development for over 6 years. We have approximately 3,500 developers using it, and with those developers, we have over 15 million lines of code and over 3.5 million runs every month. So the way it works is at the base level, we have the toolbox, which is the pyATS core test infrastructure. And this is responsible for the execution, reporting, topology, and test definitions. On top of that, we have the SDK and libraries. So the Genie library framework, that's the basis for the agnostic automation libraries. And the libraries on top of that are all of the parsers, the feature and protocol models, reusable test cases, triggers, and verifications. Finally, we have the business logic, which is where you can integrate pyATS and Genie with any application you see desirable. For example, Espresso, which is our dashboard for pyATS. I'll get into that a bit later. Ansible, Robot Framework, Jenkins, CI/CD pipelines, CLI, etc. So best of all, pyATS and Genie is now available for everyone to use. You can download the Docker version at hub.docker.com/u/Cisco test automation. You can view all our open source libraries at github.com/Cisco test automation. And you can view all of our documentation at developer.cisco.com/pyats. So currently on PyP, we're sitting at around 11,000 monthly downloads, so a ton of active users that are contributing back into our open source libraries. So on the topic of our open source libraries, the core of pyATS and Genie is lightweight and platform, feature/protocol agnostic. All platform, device, and feature implementations are open source. Feature models, parsers, and data-driven test cases are all loaded via an abstracted library layer. This means you could develop a test case on one platform and use it in another seamlessly. So currently we have over 700 APIs that you can use, 2,450 different parsers, 430 ready-to-use test cases, all across many platforms such as Linux, Junos, BigIP, DNAC, and many more. So parsers. Parsers will convert CLI output into Python data structures. So on the left here, you can see that we have output from show BGP all neighbors. And the issue with the output like this, it's hard for an application to pinpoint the data you need in a script. So our parsing function will convert it into structured data where you can actually access the data you need Pythonically. Now, the question we get asked a lot is when you have multiple different platforms, the output might look different between them. So if I write a script on one, how am I going to access the same data from another? And that's where we have the feature protocol model. So the feature protocol model, it is Yang-inspired Python class. And by that, I mean it's inspired by Yang, but it's not Yang. It is a Python data structure that represents a whole feature or protocol agnostically. And you can implement a use case for one platform and see it work on another seamlessly. It's human-friendly, programmer-friendly, and Pythonic. So this is an example of our interface model. And on the bottom, you can see all the show commands for each and every platform. So the interface model has a structure that combines all the output from all of those show commands into one agnostic structure that works across all platforms. And you can view all of the models at our Genie feature browser from the link below. So moving on, we have the command line for people who don't know how to program in Python. This allows you to take advantage of the infrastructure libraries and models without coding or programming background. For example, you could snapshot your network, and then you could make changes on it, or simply wait for the network to change. Then you could snapshot it again, and do a diff against those two snapshots, and decide whether the side effects are correct or desirable. This is an example of one of those diffs, where you can pinpoint the changes and effects. So at the top, you can see that we took snapshots one day apart for the configuration feature on the device. And you can see in the red text with the minus that we removed the no shutdown configuration, and in the green text with the plus that we added the shutdown configuration to the Ethernet 2/1. We also did a snapshot for the OSPF feature, where you can see that under Ethernet 2/1, the interface was disabled, and we lost all of the neighbors. Another usage for pyATS and Genie is automated testing. You can use it for certification tests, solution validation, stability and high availability testing, preemptive and proactive network error failure-prone detection. So to perform and to verify. So when we say perform, we mean a trigger. A trigger performs an incremental change and will ensure that that change took effect. And a verification will retrieve a current state of the device and compare it against a previously known state. And is that difference expected? So the way this works is you as a user will create the data file which drives the triggers and verifications. And that data file is ingested by the engine, which will then create the order that everything is running. So if we have one trigger with one verification, it will look like this. It'll run the first verification to grab the initial state of the device, and then it'll run the trigger, for example, shutting an interface and unshutting it. And then it'll run the verification a second time to make sure that when we unshut that interface, the device went back to its original state on its own. So it compares those, and if it compares equally, it'll pass. If it doesn't compare, it'll let you know, and then you can investigate more. So currently we have 457 triggers and 697 verifications that you're free to pick and choose for your test actions and the things you want to verify. You can let the engine build the test suite and run your combinations. So for below, in this example, the triggers are going to be unconfiguring and configuring the BGP, shutting, no shutting BGP neighbors, modifying the loopback interface IP, and shut, no shutting the Ethernet interface. And before and after all of those triggers, it's going to run those verifications to ensure that the IP interface brief and IP route VRF all are unaffected by these changes once they're reverted. And you can see below in our Genie feature browser, we have our list of triggers and verifications that you can search and view them all at. Another usage is preemptive network automation. So interface CRC error counts. Do you check them often? This is a show output of interface CRC error counts. And if we have a script that we can use to check these for you. And the script will connect to all your devices, check all the interfaces for CRC error counts greater than 0, generate a report email, and send it out to you. Can we do even better than that? Yes, we can. We can keep track of the error rate over time, because if the error rate's starting to increase, maybe you have an Ethernet cable that's going bad. And this is available free to use, open source at github.com/Cisco test automation. Next up, we have the pyATS dashboard, which we call Espresso. This is where you can use pyATS and Genie all from an interface rather than command line. And this is just one example workflow, but you can reserve a topology, select a suite job verification triggers that you want to run, let it run and see it run in action. You can analyze the results of that. And if you needed to connect to the testbed, we even create a VPN connection for you that you can connect with. Another usage of pyATS and Genie is it's a portable test automation solution. So on a single laptop, you can install the pyATS dashboard, you can install pyATS and the Genie infrastructure, you can load up the triggers, test cases, validations that you want to run, and you can bring it with you wherever you're going. You can use it for deployment automation, on-site, on-demand portable test solution, and you can even connect to devices via USB or serial to console. So automation is no longer a luxury, it's now a necessity. And network outages, sometimes they just happen. So for getting started, we only have a few simple requirements, and you need a computer with an operating system such as Linux, Mac OS, WSL, any flavors are good. We require Python version 3.5 to 3.8. You can use any editor of your choice. And finally, you just need device connectivity. To install it, it's very simple. You just need to create a Python virtual environment, and you do that by running python-m vENV, and then the folder you want to install it in. In our case, we went home directory pyATS. Once that's done, you can source it by doing source, the folder you installed it in, /bin/activate. Finally, the last step is to pip install pyATS and all of its packages. We made this easy for you, so you can use pip install pyATS square brackets full. And that's it. It's installed and you're ready to use. So we're going to jump on over to a demo where I'm going to show you how to use it. All right, so I'm in a folder here, and the first thing you need to do, I've already sourced my environment and I have pyATS installed. And the first thing you need in order to use pyATS and Genie is a testbed file. This file is where you define all your devices and all the information associated with it. So for me, in my testbed, I have one device called PE1, and I've got that device with an alias UUT. So that means I can access my device by either the device name or by the alias. Next, I have my connections set up. And in my case, I have one called CLI with the IP port protocol. And I'm telling pyATS to connect default via CLI connection. I set up the credentials I need. And then I define the OS that my device is, in my case, iOS XE, the platform it is, and then I give my testbed a name. So once you have that, you're now ready to use pyATS and Genie. So in order to use it, what I'm going to do, I'm going to take an initial snapshot of my network. So I'm going to do pyATS parse, and the show command I want to take a snapshot of. So I'm going to use show interfaces. You need to provide the testbed file. You need to provide the devices you want to run on. So I'm going to use the alias UUT. And you need to provide a location to store the output. So I'm going to call this initial show interfaces. So in my case, I'm using mock devices. So I'm going to add that argument. And then you hit enter. And what pyATS is going to do at this point, it's going to connect to your devices. It's going to run the command show interfaces. And it's going to run it through the parser and save that parsed information to a file. So here you can see it actually gives us a little snapshot at the end of where it saved everything. So if I wanted to, I could look at the console output, and this is the output. I could also look at the parsed output, which as you can see is in a nice data structure, easy to access everything inside of it. So let's say I did that a week ago, and today my network suddenly stopped working. It stopped transmitting data. So what I can do today then, I can do another pyATS parse, show interfaces, provide the testbed file, and provide the devices I want to run it on, and the output location. And then once again, I'm just providing my mock device. So you hit enter, it's going to run and do the same thing, connect, parse, and then save it and give you a nice output. All right, so with both those outputted, like I was showing before, the way without pyATS and Genie is you would have both of the console output files side by side, and you do a diff, just like this. And so this diff has a lot of information we don't need in it. And this isn't so bad if it's one device, one feature, but when you've got 50 devices and 50 features, you know, that's thousands upon thousands of lines that are gonna have diffs in it. So the easy way to do it is we have the pyATS diff tool. And to use it, you type pyATS diff and you provide the two files that you want to diff. So I'm going to do the initial one on PE1, the parsed one, and then I'm going to do the one I took today. And when I run that, it takes both the files and it runs through them and finds any differences in them. And those files are identical. Initial. Interesting. I will do it with a live device. For 1 second, I just have to make a change on the device. Seems I mocked the same device. All right, let's run that again then. So pyATS parse, show interfaces, testbed file, the device I'm going to run on, and the today show interfaces. Okay. There we go. So what it does is it creates a file, that's a text file, and it shows you where the diff is stored. So if we want to view the diff, this is all it shows me in there. So it removed all of the unrelevant information. And the way it did that, each of our parsers are designed that they have keys that are not relevant. For example, on our case, we had at the top here, we had all the packet counters. We usually don't care about that too much, so it's going to remove those. And in here, it's showing us that the gigabit Ethernet 5 was enabled, but now it's not enabled, so it got shut down somehow. Someone shut it down and forgot. Now, if you do want to see the entire diff through the diff, we have a way to remove those exclusions from the keys. So if I do the pyATS diff with the help, we can actually see that it's got the no default exclusion. So don't use the default exclusion. So if I run that, then it diffs the entire file, ignoring those default exclusions. So here we can see all of the diffs except those exclusions. So here you can see under gigabit Ethernet 1, we've got differences in all the counters. All right, so that's it for the demo, and that's it for the presentation. Thank you very much.